Okay, I'll start the presentation. I welcome you all for the two-day workshop on conservation, vegetation, sustainability of springs in parts of Western Ghats. So let us see. We have gone through the concept. What is the technical reasons behind springs? And I think both of our office experts have explained you about the springs. So now we'll see how we can use the technological part. Very handful tools where you can use it on your mobile phones or even your desktops. How you can monitor the springs, or for that matter, let us not confine ourselves only to the springs. Let us say for any water sources, maybe for the drinking water supply or any other uses, how we can make use of the technology for harvesting the water resources, whichever is available, and how to explore the inventorization of water sources. So here I'll be more focused on spatial analytics of springs in Sahyadri, that is the Western Ghats. So I'll be briefing on the geo applications, and also I'll be covering probably I think the most important part is tomorrow's brainstorming sessions, where we would like to hear from you what you are looking for and what can be integrated into this model. So we have some software, we have developed some information system. Maybe with your inputs, the field applications, we would like to update the softwares. So here, so our study area is different parts of Western Ghats. We have taken from Satara, Ratnagiri, part of Sangli, Kolhapur, Sindhudurg, and districts. So here we have taken these 6 districts for our exploration. What all we have collected is listed here. These are the very important data. Maybe in case of groundwater resources, groundwater levels are, or in case of surface water resources, major discharges, base flows, and all such things can be also collected. Here it can be updated based on the type of water supply plans which you are looking for. First is on the field data, we have taken status of the spring, whether it is perennial or seasonal. Such kind of attributes we have taken, and the discharge data. What is the spring discharge data among different seasons? Okay, and we have also conducted various socio-economic survey. I'll tell you how these technological applications are useful in collecting these things. So here we have also collected the socio-economic details. And we have also collected the water samples to check the quality of water. This is most important. Whenever you are identifying any source of water, it is very important to collect the water samples for the suitability of the water for drinking or other purposes. So then we have collected the soil data, soil samples to detect the soil moisture. Also, we have conducted various other investigations such as geological investigations and so on. So, and also to assess the reliability of the springs and how much the groundwater contribute to the watershed. So we have also made some stream flow measurements where in the lean seasons there won't be any. We have also attributed. We have modeled it where whenever there is no rainfall, there is flow in the small streams that attributes to the groundwater flow. That is the base flow or interflow. So there we have made the stream flow measurements to use it in the models where we can assess how much water potential is there from the groundwater resources. So then, along with this, we have from different departments, different agencies, we have got different thematic layers where it will give the insight of how the springs might behave. That is the geology, lineaments. One is a digital elevation model at what height the Western Ghats the springs are originating, and the slope, whether it is a steep slope, flat, and gentle slope. We have different categories, and we have got the aspect in which direction the spring is originating. We have land use, land core, what type of land use it is. Even in the forest, there is degraded forest, evergreen forest, and different type of forest, and even some have also started doing agriculture using the spring water. That also we have taken into account. And of course, this soil data that we have on the field investigations is on a finer scale. It is on the field site where the springs are available. Whereas this soil layer in the thematic layers is on a large scale. You need to know what is existing in the surroundings, whether it is a clay type of soil, clayly loam, or what type of soil is there. It is very important. And another most important thing is the geomorphology. That is how the geomorphological aspects play a very critical role in occurrence of the groundwater resources. And we have also delineated the watersheds on a larger scale for a sustainable, on an integrated development plans. And we have the spring sheds, that is a small catchments within the upstream of the spring. And the base maps, the topo sheets, Google Earth, remote sensing imageries, these things are coming under base maps. And also, we might not always get such data. We will get a lot of non-spatial data, which is on the records, which is on the publications, such as literature review or historical data, historical significance. Say, for example, some springs like Rajapur Ganga in Rajapur district have several springs which are hot springs. Okay, so it is occurring on a different elevation, and that has a different kind of behavior. It does once in signal kind of thing where it is used for the holy purposes, and certain things will happen in such cases. So we have historical data of such springs, and certain springs which are unexplored in the Western Ghats might not have any historical data. So we have also collected some historical data. We have collected photographs, dimension measurements of the harvesting structures where they have harvested the springs. So we have taken the dimensions of the tank, what is the harvesting structure, and all that. And we have simulated those data in the hydrogeological modeling softwares such as Hydrus, ModFlow, or SWAT. So a simple the software is a SWAT, which gives based on SCS curve number method, we'll get the recharge, we'll get the surface, and all the water balance components can be obtained from water balance charts. And we have got the hydrographs from the field measurements. We have got the rainfall data. We have got the temperature. Using all these, we'll see how we have developed the database and how we can utilize that. We have went to the field both pre-monsoon and post-monsoon, because in monsoon season always it overflows and there's no significant the spring discharges will be 100%. We have taken in monsoon seasons also the measurements we have taken in monsoon season, but the most critical is the pre-monsoon season, where that is the summer season, where how much we can have the dependency of the spring water. So this is on the pre-monsoon 2018. We have measured for last 3-4 years. Post-monsoon 2018. So immediately after rainfall recedes, say for example the rainfall has stopped, what is the behavior of the springs? Whether it discharges immediately and goes to the nil status, or it slowly discharges, all such things are observed in the hydrographs. So, and this is in post-monsoon 2018 of Sindhudurg district. And here you can see in post-monsoon they have got good amount of water. We have also done the social and economic survey. These were the measurements which I was talking about. These are the measurements of the harvesting time. And this is the spring water in a small village of around 700 population. So this is another this in Devrook there is one spring, and the population is around 500 people. So here you can see how they have harvested. This is a different kind of structure. It's a kind of well structure. So there are different kind of structure depending upon the terrain and where it is occurred. So this is in Gargoti, that is in Kolhapur district. So we have taken some sample springs all over to study the behavior of the springs. This is the in the lean season. You can see how is the discharge. This is the post monsoon after the rainfall has receded. So we have taken discharge details. What is the velocity? What is the amount of water? We have taken the cross sections. We have measured the spring discharges. Above this is the Western Ghats. And the upstream of this is Western Ghats, where most of the springs originate. So here in Belgaum also there is springs, that is in the Kanbagi, that is Untitled Temple. It's a beautiful place. It is a nearby place. We'll be having a site visit where you can see how geologically I think sir can explain you the beautiful manner on these springs. So this is in Kanbargi. We have been closely monitoring this on a daily basis more often, or at least we have measured on a weekly basis for past 1.5 years. And of course, pre-monsoon and post-monsoon from 3-4 years. So we have measured this, and we have got students who had went to the field visits, and they have also studied various geological aspects of the region, and we have done a case study on that, and we also developed the action plan for the smart city for harvesting this space. So this is in 2020, and these were the field investigations. Sir was involved. He was personally involved in such tough terrains. He was measuring all the overburden depths and what type of soil is. We have collected all the layers here, and here we have made the slope map for this region, and we have generated the aspect map. Aspect map gives the directions, flat, northeast, east, and different directions. So it gives what directions it might be occurring, the springs might be occurring. You can analyze that. These are the lineament map, geomorphological map, and geological map. And when we analyzed, we also saw that in springs in the Western Ghats, you can see the cluster of springs which are seen here is on the higher reaches, that is on 450 to 1200 elevations. So here, as you can see, a cluster of spring occurs here, and there is a cluster of springs which is occurring less than 200 elevation. This is on lateritic terrain. So on the coastal belt, wherever the eastern side, on the western side, this is the case on the lateritic occurrences of springs. Whereas in a basaltic terrain on the higher reaches of the Western Ghats, this is the case where on the higher reaches you can see how the spring occurrences are seen. The statistics are given here, and also we have also analyzed from what distance on the peak of the Western Ghats, that is the ridge of the Western Ghats, at what distances how many springs are occurring. So we have taken the buffer distances, and we are seeing that less than 10 kilometers of the Western Ghats, we can find majority of the springs, 250 springs out of. We have explored around 780 springs in this case, whereas we are keep updating this. As sir told, we have explored more than 1,000 springs, whereas for this stage of the study, we had explored 780 springs. You can see within 10-kilometer range of the Western Ghats, you can see nearly 250 springs are occurring, and within 20-kilometer range within the core Western Ghats, so we can see nearly another 218 springs. So this is one of the observations, and according to the slope, what type of springs are perennial? So we have some are seasonal, some are perennial. Whereas we have seen in Sindhudurg district where it was a Butwewadi village was there it is perennial. Off Amboli, on the western side, where there is steep slope, and there are villages on a little lower level. there are very we have done through that socio-economics.
It's transformed over the years. Actually, it was a perennial stream, stream. Then slowly it converted to a non-perennial. This is another business. So our idea is to now rejuvenate the entire purpose of this study is to make it instead of seasonal to make how best how we can try that purpose.
Service terms are best. Spring setting.
Yeah, spring months.
Spring setting,
Spring setting needs to recharge that recharge zone we have to demarcate the store.
Yes, it's a great setting.
Actually, by seeing the spring, even delineating partnership, friction is nothing but a small.
So I went to the state department of forest sales.
Yes,
that's some birds.
Yes, that's exactly. So you invited them also due to some activity.
Because water consumption during summer season.
Yeah.
Soil life coming to the sea. Right.
Actually, research of water is very essential to the business about wildlife. It's very essential.
So here we can see the behavior of the springs where 15 to 35% steep slope. This is steep slope. It occurs in steep slopes of the Western Ghats where 15 to 35% we can see highest number of springs. So not very steep. Where if it is greater than 35%, it would be a very steep slope where less number of springs are seen. On this moderately steep slope, we can see more number of springs in the Western Ghats. So and aspect wise, there is no particular findings where almost equally distributed in all directions. Western Ghats. That shows that the faults and fissures and the lineaments are distributed in all directions. So geomorphology, geomorphologically here it is on a moderately dissected lower plateau. That is thick, but the basaltic terrain, most of the springs are like that. The next highest is on the delimitational origin. So there is no much significance here. And geologically, this is nothing but the basaltic, where highest number of springs are seen, and lateritic some are seen. Other and we have done the hydrogeological modeling using SWAT. We have used the elevation models. We have used land use, land cover, and we have derived the soil from the field investigation as well as the courser level from FAO. Rainfall we have got from Bhujal, that is from GSDA. For the state of Karnataka, we have also got from WRD. Weather parameters, we have taken the needed database. Spring water quality we have. So here you can see, this is in the Kolhapur district. You can see this green color will give the spring behavior. This is the actual groundwater discharge. This is the rainfall. After rainfall occurs, there is a lag for the groundwater discharge, continues for few months. And as you can see, this lateral discharge springs are not a major source of water, but it gives sufficient amount of water for a survival of small villages. It can supplement to a certain extent in the lean season. That is more important. So similarly, in Ratnagiri, what happens? The geology changes. It kind of lateritic. It's on the west coast. So as it goes down, the behavior is seen on a different mode. Here you can see the lateral flow also follows in lateritic terrain. There's no much delayed response to the spring discharges. So here it's a different kind of behavior. And this is on a Sindhudur district. This is on the off Ambuti Ghat. So this has a different kind of behavior, as we told, on the steep western side of the Western Ghats. And this is in the Satara district on the eastern side. You can see now the difference between eastern side and western side. This is on the eastern side of the Western Ghats. And this is Belgavi also, of course, it's on the eastern side, rain shadow side. So here we have done the detailed analysis for this. And this is the portions we were talking about, the lateral flow. After the rainfall, this is blue color is the rainfall. After rainfall recedes, you can see these discharges play a prominent role in supplying drinking water during the summer seasons. They are not worried in the monsoon season. They are most worried in the summer seasons, where in the Western Ghats, it is very difficult to commute to that place, and they are deprived of water sources. So these play a very important role. As we can see, the spring water quality is almost meeting the best of the standards quality. So you can see the limit is in the red color, whereas all the springs we have monitored nearly 25 to 30 springs in different sectors. We have chosen into different typical examples. So all such springs gives a very good water quality results. Here you can see, whereas the limits are very far away from what we are getting the results. So we have analyzed for different parameters, and what we have done is one as an outcome of the study, we have also developed one mobile app where different, even the common persons or even the planners or the decision makers, the researchers, anybody can explore such things and update the information. So we have collected smart information where they can collect the details of the springs. They can measure the monitoring and all that, they can do it. And here, and also for the exploration of the springs, we have done this. You can watch a small clip on this, how we have developed. The link is on the QR code. Once you scan that, you can see, we'll get to know what are the springs around us. So possibly the planners might not know where the spring exists. So such springs we have done. Not only we have located the springs, we have also given the attributes for the springs. What is the possible discharge? What is the behavior of the springs? What is the geology? And how much dependency they can make on these springs based on the hydrographs. Based on the analysis, we might give the typical discharges. See, there we are given that 150 liters per minute is expected out of the springs. So we have given the springs, these are the field investigation. We have also given the water balance chart. We took up chart in this application. And to add upon this, if you want to have the route map to the springs, that is also generated out of the springs. So it shows how much distance is the spring from the current location. So that is also done. And we also have the web application. Web applications will give the on the desktop, on the office purposes we can do. But whereas the more useful thing is the mobile applications, where wherever you go, and those data which is collected, these applications will work whether you have the network or whether you don't have the network. It is already downloaded with your cell phones. You can collect the data, and whenever the mobile network comes, that will be submitted as the updates to this. Wherever, say for example, we have got some field observers where some college students, we have actively involved them into this picture, where they constantly send us the discharge comments. So such things will be coming to us whenever, of course, in the Devruk field site there is no network. Whenever it comes to the cities, the college purposes, thing gets updated, and we'll get the discharge details. So that is about the information system on the springs. And on the web application side also, we have the desktop version.
Most of the rest of the provided with equity.
Yeah, no sir.
So you see, traits are spread majority of the landscapes are traits in there, which we tropical climate western climate. So the entire western climate is under the tropical climate. Tropical climate, whether it is more, that is why when the any type of nice functions don't matter, it is igneous or metamorphic. We let the refining to black traits. So black soil, what happens? Black soil conditions is everything. That's why it is not spread over the climatic reasons. That is, you are right. The western Ghats, if you take right from Lebanon, is
Things can operate not in
Why that makes sense?
but there are most festival
Language in the name of the context is only language.
Yes.
that's the way they see.
So here, as you can see, we are given which side it occurs, and, latitude, longitude, what is the slope percentages, what is the aspect value, and what is the elevation it occurs, what is the geomorphology, and what is the geology, state, and we have got all the villages, and we have also got such cases where the deep western Ghats. I can show you some examples on that. In this village, we have got all the details, including water quality parameters and also what is the number of households, what is the purpose they are using for drinking water, it is perennial. We have got the field photographs and all such things. So here, the area of the village, number of households is 171. The population, as I told you, around 500. So 567 is there. So we also generated a spring code based on the alphanumeric nomenclatures. So we'll give the count of the number of springs, their behavior, and we have attributed some technical information so that it can be utilized by the planners. So this is our information system. This can also be attributed to, say, for example, any drinking water schemes or water supply schemes. So we are also planning to build some water database here in and around the regions. So what might be the position, water potential at any place. Here, this app can be used, say, for example, at my place, say, anywhere in the city or outskirts, peri-urban areas. I want to know what is the geology and what might be the expected outcome of the water. Such things also we do. So we can plan such things where it can be utilized by the common people.
For example, water level. You are going to give the water level. For drilling, etc., it will help.
Yes.
This area.
So sometimes, say, groundwater levels you have on a observation scale. Say everybody can input the data. Maybe in the future, say every individual, say for example, I have a open well in my house already. So they start giving the input into the software. So others can utilize what might be the possible water levels in their position. All such things can be developed in this case. So it might be useful for the department. It's like a public eye. Now in Bangalore, they are doing traffic violations. They have given the rights to the public that they can give a photo and they can launch a complaint to anybody who is violating the traffic. Something on a similar scale we can develop for the water resources.
What's the status of Plato springs? Deccan Plato River. Springs.
Like ಈಗ ನಾವು ಸ್ಟಡಿ ಮಾಡಿರೋ ಆಕ್ಚುಲಿ ಕೇರಳದ ಅವರು is different. We are trying to all integrate the entire system. ಈಗ ಹಿಮಾಲಯದ ಮತ್ತು ನಮ್ಮ ಇನ್ಸ್ಟಿಟ್ಯೂಟ್ ಹಿಮಾಲಯದಲ್ಲಿ video you can small video of where we are going now. You can just a small video, 3-4 minutes. Then we will start. You have to do it almost still it is working. It's still working. Actually, it was the video was done by our students' husband. They are kind of so well it is so well delivered. Yes.
So, show you this. This is the so here we are using the mobile app. This is a demo on that. Say how we collect the data. Once we do the collection, so this is the collect. So you will ask the name of the investigator, phone number, also take the location of the field surveyors, and you can give the area. Once they select either the direct discharge or the depth of the river is there, it is direct discharge, and we will get a checklist of instruments. What all he has to carry, what is the volume of the container, what is the time to fill the container. In seconds, we will also have a calculator ready invitation, and you will get the discharge. And you can also take the site photos. We will upload here. We also have the social here, where with the name of the localite, this is phone number, if any identity details is there. And you give it the whole conversation in the audio recording message, you can send the details to our server. So once it comes, it immediately gets updated in the database. So the option was here the depth of flow. Once the depth of flow comes, they need the velocity, stopwatch, measurement tape, and taken to model. Once they get what is the shape of, in certain cases, we have seen the vertical board measurements. So we have also mentioned all the details. Once they measure the discharge, they can upload these details into our system. So we will update all the spring database that we have also created spring information system as a database for use for the government departments. So any discussions in this regard or your views? We also have a tomorrow session on installation session. We can give your inputs so that we can discuss on these aspects. Thank you.
Presentation. So now we will leave for the field. Whoever is interested, whoever is there, one of the is there. Please, and depending on the we will bring you back here.